Welcome to Fast Math Solutions on Maths with EJD. In this video, our question is what is currently displayed. Integrate with respect to x. Arcsin of x. Arcsin of x. Integrate with respect to x. So we need to get the integral of arcsin of x. That means we can say that I is equal to the integral of arcsin of x with respect to x. That's dx. Now, if you look at this, normally the first instinct is normally, if to differentiate sine x, of course, how we actually do this whole sine and cos thing normally is if you differentiate sine, you get cos. So that means if you integrate cos, you get sine. So if you differentiate cos, you get minus sine. That means if you integrate sine, you get minus cos. And then other things derive from that. But in this case, it doesn't look like we can actually integrate arcsine of x directly. So the next question is, once you cannot differentiate directly, what other methods can you use? Well, I think you may want to consider something like integration by parts, where you have your I to be equal to uv minus integral of v du. In fact, technically, that's actually something like I is such that, let me put it this way, I is such that integral of v du, or better still, integral of u dv is equal to uv minus integral of v du. So what it simply means is that you actually need to find out a particular, you need to know, you need to distinguish from here, you need to call something u, and this u is going to lead you to du. So it means you should pick something you can easily differentiate. All right. And then you need a dv, something you can easily integrate to get v. So u here, and then you have du here. So it means from your u, you are going to get du. And then you have dv here. From your dv, you are going to get v. So it means your u should be something you can easily differentiate, and your dv should be something you can easily integrate. Now, of course, it's clear that you cannot easily integrate arcsine of x. So what do? So, of course, you know that you can rewrite I to be something like integral of arcsine of x times dx, or if you like, times 1 dx. So technically, times 1 dx. So here now, you can easily, at least, maybe not so easy, but at least you still know you can differentiate arcsine of x. To integrate it is like out of the question. And then it is easy to integrate dx. Just integrate dx and you get x straight up. So, and that's exactly what we're going to do. So here now, you say, let u be equal to arcsine of x. And since you need du at the end of the day, so you have to go ahead and differentiate. And how do we do that? Well, I'll go through the process. Though I've done this in the previous video, but let's take the pain. Take the sine of both sides. So you have sine u equals x. If you have sine u and sine of arcsine of x, that's simply x. And then we need du dx, right? So you can say d dx of sine u. Oh, yeah, we are differentiating with respect to, we need du dx for sure. So you say d dx, all right, of sine u equals d dx of x, all right? And it's difficult to just do d dx of sine u. So you can do d du of sine u balanced out with du dx, so that du cancels d. So you still have your d dx technically, all right? And then that is equal to d dx of x. So we can go ahead now. If you differentiate sine u, d du of sine u is like derivative of sine u, which is simply cos u du dx, and d dx is simply 1. So, don't forget we had u, now we need du. So it means that du dx is actually the same thing as 1 over cos u. But then we are not done, because we need something in terms of x. So you want to remind yourself that sine u here is actually x. And then we can write and we know that sine squared u plus cos squared u is equal to 1. So if you have cos u here, so that means that you have cos squared u equals 1 minus sine squared u. So that means that cos u alone is square root of 1 minus cos square 1 minus sine squared u, 1 minus sine squared u, which is the same thing as saying that cos u is square root of 1 minus sine u all squared. And then you already know sine u to be x. So it means that cos u is simply square root of 1 minus x squared, right? Because sine u is x. So that is by the way. So in that case now, you can go ahead and do what you have to do. So now you can say that du dx is equal to 1 over square root of 1 minus x squared. So that's one part of the story. So the second part of the story is, of course, we have identified u. So automatically we have to, so it means that dv, don't forget, this is the formula, integral of u multiplied by dv. So you have found u, so you need dv. So and from dv, you're going to get v. That means you're integrating this to get this. So dv now is the same thing as 1 dx, which is simply dx, right? So since you need v, so you can just say integral of dv equals integral of dx. And integral of dv is v, integral of dx is x. You can add a constant for the sake of it at this point. So that's what you have. So now you have you have you have u, which is this, you have dv, which is dx, and you have v, and then you also have du dx. Of course, what you need is actually du. So du is actually 1 over square root of 1 minus x squared, okay? So that's the end of an era, right? So let's move on from here and put together all what we have. So let's go green as I now have, so you now rewrite all that. So you have I now, so you can say therefore I, which is equal to integral of arcsin x dx, is simply the same thing as the integral of, so it's now like uv minus integral of v du. Or let me put it down here so I don't have to struggle getting into that corner. So I now is equal to uv minus integral of v du. So what is u? You know, u is, again, u is arcsin of x. So u is arcsin of x multiplied by v. What is v? V is simply x. You can leave the constant for now to avoid confusion. So v is simply x minus integral of v. Again, v is x. And then du, that's this. Du is 1. Okay, so du is 1 over root 1 minus x squared dx actually. All right. So you have this over root 1 minus x squared dx. So if you tidy that up, it's more like you have I equals x arcsin of x minus integral of x over square root of 1 minus x squared dx. Now, this looks like some very big problem, but I don't know. Let's check. Normally, this is looking like you should do trigonometric substitution, but don't be too fast to decide that, because if you can check this out already, if you differentiate 1 minus x squared, you get minus 2x. And somehow, you know, once you can get x out there and there's still one x standing aloof here, then it means they can easily cancel out. So that's your ticket to not having to do trigonometric substitution. So as far as the x can cancel out, you don't have to worry. So now our focus, okay, well, I mean, to tell this apart, we can now say I is x arcsin of x minus, then we can call this I1. So it means that this integral is I1. So we can take that and say, so I1 now is equal to integral of x over square root of 1 minus x squared dx. So again, you start another journey altogether. So you say, we've used u before, we've used v. So let's go w. So we can say let w be 1 minus x squared. And once you do that, that means that dw dx is equal to minus 2x, because when you differentiate 1, you get 0. When you differentiate minus x squared, you get minus 2x. And then you need x, right? You need this dx to be replaced. So you have minus 2x dx. That's you cross multiplying now. Minus 2x dx equals dw. So that means that dx alone is equal to minus dw all over 2x. And that looks good for us because, you know, d minus w over 2x is coming to replace the x. So, and x can easily cancel out. So that's so sweet. So let's go now and continue the journey where we can say this, that so again, I1 is equal to integral of x all over, of course, square root of 1 minus x squared now. That's w, and dx is minus dw all over 2x, like that. So I am very happy to cancel this out, and then you have minus and 1 over 2 here. So I1 is equal to minus 1 all over 2 integral of 1 over w raised to power half, let me write that properly. Square root of w is w raised to power half, then dw. The minus is out, the 2 is out, so we have that. So that means that I1 is equal to minus 1 over 2 integral of w raised to power minus half dw. And then we can integrate this straight now because, I mean, we can easily increase the power by 1 and divide by the new power. So I1 now is minus 1 over 2 into w raised to power minus 1 over 2, add 1 to that, divided by minus 1 over 2 plus 1. All that plus maybe constant c. So everything is looking good. So the next thing is to tidy all that up. So we have I1 equals minus 1 over 2 into w raised to power half all over half, okay? So, well, of course, don't forget the constant c. So that means that I1 is equal to minus 1 over 2. Of course, 1 over 2 here, 2 can go up. So you have 2 w raised to power 1 over 2 all over 1 if you like, plus c. So these 2 cancels this out. So I1 actually is equal to minus w raised to power half plus c. And don't forget w, we didn't always have w, so don't forget w is 1 minus x squared. So you can pull that back. So you have I1 is equal to minus square roots. Of course, maybe let me just do it like for a layman. So minus square root of w plus c, right? So that means I1 equals minus square root of 1 minus x squared plus c. But this is not where we came from, right? You have to remember where you're coming from. Remember your source, okay? So let's go back to where we came from. So remember the last time you saw I1 was right here, okay? That's not looking good since that's the same color we've been using. So, I mean, remember where you are coming from. So, and that place is this. So where I equals x arcsin x minus I1. So I can tell you to recall. Okay, looks like yellow is not always the best. Let me go kind of blue. So again, x arcsin x minus I1. Recall that I equals x arcsin x minus I1. So you can now put this in the place of I1. So I now is equal to x arcsin x minus I1. So that is minus minus square root of 1 minus x squared. All right. Uh, you know, plus c. You can just put the c outside, it's some constant, so that I equals x arcsin of x plus square root of 1 minus let me write that properly. Some perfectionistic thing going on here. So plus 1 minus x squared plus c. And then this turns out to be the derivative of that expression right there. Okay, so that actually goes. So that is the derivative, right? What's the question again? I like to always remember where I came from. Integrate with respect to x, arcsin of x. Okay, so you can just say therefore the integral of arcsin of x is what we have now. X arcsin of x plus 1 minus, plus square root of 1 minus x squared plus c. And that is how the journey has been. So thank you so much for listening. Remember to subscribe, hit the like button, comment, share. If you want us to solve some problems, so put it in the comments, and then it can be on the queue, and then we'll attend to it when the time is ripe. Thank you for always coming along with me in this interesting maths journey. See you in the next video.